Okay, so hello and very good evening. We'll start with my internship session. So first, as always, we'll conduct the presentation session and then we'll move on to general discussion. So first is Hemang Raj.
Hello, good evening, sir. I hope my camera is visible.
Yeah, you can start.
Yes, sir. I'll share my screen. Sir, I hope my screen is visible.
Yeah, it is visible.
Yeah. So, good evening, everyone. My name is Hemang, and I'm from machine learning and deep learning domain. My task was to perform EDA on credit card fraud detection, and I am presenting the same. So, first, these are the contents which I will be going through my presentation one by one. So, please bear with me for the next few minutes. First is what is exploratory data analysis? EDA is exploring and getting to know our data before diving into the analysis. I'll give you a simple example for that. We have a set of data. We want to perform some operations on that. So to know what our data has, to know the depth of our content of our data set, we perform EDA. I'll give you an example. Just suppose that you have to go to a party. You have a party to attend. Now, when you go to your home, you open your wardrobe and you see what shirts or t-shirts you have, what pants or trousers you have, and what shoes you will wear today. So you try the permutation and combination from the available clothing sets of your wardrobe. Same thing we do with our data. We cannot generate anything new. Whatever we have to use those data to get the desired output. This is exploratory data analysis. The first step is to load the data into a suitable platform. So I have used Jupyter Notebook to load the data. Jupyter Notebook uses Python language. So this is a credit card data. So in credit card data, what all features we can have is name of the person, transaction amount, and other things. But as this is a very confidential data, all the nomenclatures have been changed to principal components. V1 to V27 are the principal components which I will be using to perform the analysis. First, we need to understand the data. The three major components of our data are time, amount, and other principal features. I'll show you the data. I hope my data is visible. This is the Excel sheet which contains the data. Now we can see there are many numbers. The the first column has time and the next 28 columns are V1 to V28. Then we have amount and class feature. I will come to class feature later, but for now, time and amount are the two important aspects to dive deeper into the analysis part. Next, we have to load the data and check the endpoints. This is the Jupyter notebook. Here I have loaded the data using pandas and seaborn. After loading the data, we have to check whether the complete data is loaded into Jupyter notebook or not. For that, two important commands are df.head and df.tail. These two commands gives us the first five and the last five rows of our data. These are the first five rows and these are the last five rows. As you can see, the data is around 2,84,806. So any data which has such a huge number of transactions cannot be worked upon just by using the numbers. So we need to visualize that data using relevant visualization techniques like histogram or pie chart. So after loading the data and checking our endpoints, we have to estimate the size of the data and describe the data. For that, next, this is df.info command. This gives us the information of our data. We have V1 to V28. These are the float data types, and amount and time also is float data type. Class is having the integer type of data. That means we have 29 float types of data and 38 is integer type of data. Next, I'm using print df.shape and df.describe. Df.shape gives us the matrix of our data. We have 22 around 2,80,000 rows into 31 columns, and df.describes describes the data. Describes the data in the sense mathematical description of the data. What is the count of that row? What is the mean? What is the STD stands for standard deviation? What is the minimum value? What is the maximum value? 25, 50, and 50% are the interquartile range of the data. Next, we have class feature of the data. So why do we require class feature of the data? In this data, the last column represents class. Now the class value is 0 for all the transactions which are legitimate. That means which are real transactions. And the class value takes 1 wherever we have fraud transactions. So for us, we need to work upon the data which are fraudulent. For that, we have to perform the mathematical calculation, and we get that total number of fraud transactions is 492 in our data. So here we can see out of 2,84,000 data, only 492 are fraud. So if we were to segregate these data using manual calculation, like we needed to see the Excel sheet and then we have to mark 01 is 01, it would take a huge amount of time. But using just 3 4 lines of code, we can do that in a very short time. And that amounts for about 0.17% of the data is fraudulent. Now I have described the fraud features of the fraudulent data. These features, out of 492 transactions, the mean value is 122, standard deviation is 256, minimum, maximum, and interquartile range. Same thing here is for valid transactions. For valid transactions, the count is given, the mean is given, other mathematical features are given. Now we need some visualization techniques to visualize the data. These are the details of fraud and legit data, which I just showed in the Jupyter notebook. Next is heat map. So what a heat map is? Heat map is a figure. It is a representation of dependency of variables of each other. In heat map, it is just like a map where deeper colors represent that these two variables are correlated in a very strong manner. So we can see this is the heat map. The diagonal values are null because v1 to v1 relation is a null relation. Other features are mapped into this. So using this features, again, we can perform some modeling or other tasks, which is not required here. Next, we have to give the interquartile range. We have to detect the outliers. So what is an outlier? This is the heat map and outliers. Outliers in simple terms means the data which are very much far from the real data. For example, if we take marks of 100 students in a class, the pass marks is 35 and 90 marks is the distinction marks. Above 90, we get distinction. So the range of marks from 35 to 90 is considered as normal marks, and any marks below 35 and above 90 is an outliers, because very few will be having less than 35 and very few will be having marks above 90. So we consider those as outliers. So detecting outliers is an important case for us. But in our case, this is the outlier. This is the formula to calculate the outliers. Define outliers. Q1 minus 1.5 into IQR. IQR stands for interquartile range. This is general formula to calculate IQR on any data. But in our case, we are getting 1,38,000 outliers. What does this mean? This is not useful for us in our case now, but still I have included this outlier case. Why? Because we must know the concept of outlier, and why we are getting such a huge number for outliers is when we say transaction data, a transaction can range from rupee 10 to rupees 1 lakhs in a single day. A person might be using his credit card to buy tea of 10 rupees, and another person might be buying stocks worth rupees 1 lakh. So transactions amount can vary from 10 to 1 lakh. So detecting outliers in this won't be of any use to us, because when we are talking about huge population, there are lower class people, middle class people, and high class people who have different spending capacity. So outliers is not much useful for us. So the next feature of our data is correlation matrix. Correlation matrix is a square matrix that displays the correlation coefficient between multiple variables in a data set. We have variables v1, v2, v3, amount, class, time. To represent the interdependency and correlation between them, we use correlation matrix. These are the relevant codes for correlation matrix, and the correlation matrix which we get is this one, between v1 and v2 between v2 and v22. These are the values we get. If we want to perform any modeling or prediction task on that, we can use these values to perform the same. Next is column distribution in dataset. So we have v1 to v28 columns. Now each column has certain impact on the whole dataset. Whole dataset is affected by these columns. To find out till what extent a column is affecting the whole dataset, we can plot the column distribution graph. So this is the column this is again the heat map visualization of correlation matrix. This is the column distribution graph. Here we can see that till what extent which column is affecting the dataset. If I plot those columns individually, see, this is the column of v1, this is the column of v2, this lies from 0 to 500, this lies from 0 to 250. Like this, we can find the column distribution in the whole dataset. So overall, using our dataset, we could see that within a few minutes, we could find the number of fraud cases, number of legitimate cases, Then after finding the fraud and legitimate cases, we could find the mathematical descriptions of the same. Using the class feature of the data, we created a heat map, and then we detected outlier, which was not much useful in our case. Then we did a correlation matrix to find the interdependency between variables. Then we found the column distribution of dataset. So overall conclusion is EDA is a very powerful way to know the dataset of our data in depth, because without EDA we would be looking at the huge Excel sheet with around lakhs figures. So it is very difficult to play with numbers. So we visualize those numbers using EDA. Next is I have used Jupyter Notebook. So Jupyter Notebook is a very good way, and it uses Python to implement the visualization techniques. So Jupyter Notebook is really a very good tool for data analytics and visualization. Then our data, which is credit card data, is efficiently worked upon to find the fraudulent cases. These are the references I have used. The first one is Kaggle, from where the dataset is downloaded. The second and third is RapidMiner. Using RapidMiner, the data pre-processing is done so that data is clean, data doesn't have any noise, and any unwanted outlier values are removed. So this was my presentation. If you have any questions.
Okay, I hope now I'm visible. I hope you are done with your presentation now.
Yes, sir, I'm done.
Okay. Okay, so I would say a really good presentation. Okay, you have improved a lot with respect to your overall look as well as the story part. Okay, but second thing is your overall content was good, but it can be improved. Your task content can be improved. See, you explained all the important things such as, let us say, correlations and main points of your presentation was well explained. But the small points, I believe you were quite rushed. Okay, you rushed it. So try to be more in depth about something. Let us say when we are doing something or when we are executing a command, let us know why we are actually executing that command, right? So if you are finding any kind of null values or something, so what is going in your head, what is your thought process while doing the certain thing? Because EDA is quite a diverse subject where we are just exploring the data. We don't really have end goal. We can find anything, and that is the point of EDA where we are trying to find something. So let me know what is the thought process while doing this thing, what you are trying to actually achieve, or what you are trying to find, or let us say you have some kind of expectation and what you are actually able to find. That will be much more preferable. It will be much more better. Your viewers can also easily understand why we are executing this command, or why we are checking for the correlation values, or let us say why we are actually finding mean or other values, right? Because let us say if I have a data percentage of students, right, then finding the mean of the percentage will be make sense, right? Because we are trying to see what is the average percentage of all the students in our class, right? So class wise mean finding, that will make sense. But in this case, does it really make sense, right? So you have to explain this thing, why we are actually finding this thing. So what's the point of finding this thing? You have to be more specific about this so that technically your presentation becomes much better, because you see you are able to explain things really well, and also your overall story and overall communication skills are really great. Okay, but you need to work on overall your, I would say, how your viewers are getting your presentation, how they are able to say. Let us say you are showing the demonstration on Microsoft Edge as a PDF, right? But the visibility was not really great. Okay, in the Edge you can go full screen and make it 100% with your overall PDF. The visibility will be much greater. Okay, so see, I would recommend you before you join this meeting, make a meeting of your laptop and your phone and try giving a presentation. See how, what is the user experience. Okay, then your overall user experience will be much better when you are giving the presentation. Okay,
Yeah. Okay.
that is the improvement that you can do. Other than
Yes,
that,
sir.
you are going in the right track. Here is visible improvement from last time. So
Yeah.
good. Okay.
Thank you, sir. Yeah.
Yeah, thank you very much. So we'll move on to Akash. Yeah, Akash. What is the name of your topic?
The project timeline.
Okay, please turn your camera and share the screen.
Okay, sir. My screen is visible.
Oh, yeah, it is visible.
Okay. So good evening, everyone. My name is Aakash, and I am from Web Developers Group. And welcome to the presentation of Project Real Time Stock Market Data Web Application. And the task name is Project Timeline. Okay. So this is the table of contents. So first I'll be giving you the project overview, and then I'll be discussing the tech stack used, and then I'll be discussing the steps I took to make this project timeline, and then I'll be giving you the timeline document demo, followed by the challenges faced and the conclusion part, and then the references, and at last the doubt section. Okay, so basically, what is real-time stock market data web app? So as you know, a company basically releases initially its stocks during the initial public offering. So one can buy stocks at that time or through different exchanges like the uh, Bombay Stock Exchange, New York Stock Exchange, different exchanges. Or even if someone has not purchased a particular stocks, then he or she can trade those stocks at different platforms like Yahoo Finance, Google Finance, or other platforms like Grow and platforms like these. So basically what our website does is it is basically a full stack web app, and it helps in keeping a track of real-time stock market data, and it displays this data in easy to understand format. And basically these this website will be used by investors, traders, and other financial professionals to make informed decisions of buying and selling stocks. So this is about this web application. And then now, what is a project timeline? So a project timeline is a visual representation of a planned sequence of events or activities that are required to complete a project. And basically it outlines the start and the end dates for each task or activity, as well as any dependency or constraint that may impact the completion of a project. So basically it tells like which are the tasks which are completed and which are not completed, and actually who are responsible for completion of these tasks. So like it often sometimes include the cost of the project and also the time frames in which these all the tasks will be completed. And basically the feature of a good time project timeline is that it should be in depth, but it should be easy to interpret, and it could be understood by anyone with ease. And making a timeline document encourages teamwork and also brings accountability among the team members. And it is one of the most important tool to manage any project, and it makes the project successful. So let's move ahead. So benefits of a effective project timeline: increase accountability. So as you all know that for the successful completion of a project, the project is divided into different subtasks, and each member is given these subtasks, and each member knows its responsibility well. So this timeline brings accountability to the project, and each members have a particular responsibility assigned to it through the timeline. So it definitely brings accountability. And the second is it also serves as a source of motivation, as the written timeline will help the team members to understand their role in the project, and it will help them to move ahead. And one of the most important feature of the timeline document is progress tracking. So basically, once you have divided the project into different subtasks, and then you will be assigning different checkpoints and milestone in the timeline document, and you can keep progress meetings, and you can ensure that all the tasks are completed within deadlines. So it is a tool for progress tracking. So what are basically the main deliverables of a project? So these are the three things which are often confused but they are different, completely different things. So first is the project plan. So what is basically project plan? So it is basically a formal outline of the project. It tells about the goals, stakeholders, scope and responsibilities of a particular project and the schedule of the project. So it basically helps the team to stay aligned throughout the project. And then comes the work breakdown structure. So it is basically it is the breaking down of the large deliverables into more manageable parts. So it does not detail how the each task has to be done, but it like identifies different tasks which are necessary for the completion of a task. And then finally comes the project timeline. So it is the actual visual representation of these tasks, and it will these are the it will basically contain the starting time, end time, the different dependencies and bottlenecks of different tasks. This is the actual part that contains those things. So let's move ahead. So the tech stack used is Google Docs. So it is used for making the timeline document. And I've used Jira software for making the timeline. So basically, Jira software is a project management software and developed by Atlassian, and it is widely used for agile software development. And it is a powerful tool that allows team to manage their work and collaborate within the team members, and also report on project progress. So let's see the steps to create a project timeline. So first and foremost is write and approve a project plan. So as you know that for the successful completion of a project, you must have a plan. So this step basically involves identifying the scope and the features of your project, and you need to identify what your actual goals are. And also you need to talk to the stakeholders and understand what are their actual requirements for the project. So this steps involves that. And then moving on, the step 2 is generate a work breakdown structure. Okay, so once you have understood the first step and identified all the scopes, features, and the talk to the stakeholders, you need to divide your project into different subtasks so that these can be managed and monitored individually. And it will like basically help your team to have a clear idea of what are all the tasks that you need to do, and what are the resources which you will require in completion of those tasks. So let's move to third step. Basically, now you have to create specific project tasks. So once you have created the work breakdown structure, you need to now divide those tasks into subtasks. Now here you need to assign you need to identify which tasks are needed to completed first, and then which are to be completed afterwards. So you need to assign different priorities for these tasks and assign deadlines, and also you need to update regularly about the information on these tasks so that the timeline document is updated. So step 4 is sequence the steps and estimate the time required. So basically here you need to complete all these tasks in a particular order. So you need to identify that order, and here you need to identify the different dependencies. So dependencies are the tasks which are needed to be completed for the completion of some other task. Also, you need to identify the different bottlenecks in your project. So bottlenecks can slow down the progress of your project, and you need to minimize the disruptions. So identifying the bottlenecks will minimize the disruptions. Also, yes, this is about this step. Then the next step is choosing a project timeline software. Okay, so you have different types of software available. So if you want to do effective scheduling of the specific tasks, then you can choose the waterfall style Gantt charts, and it provides a timeline view and is good for status tracking of the project. And or if you want to do a kind of a flexible make a flexible timeline document, you can choose this Kanban software. It has a more agile approach and helps visualize a project in a completely different way than a Gantt chart. And then step 6 is construct your project timeline. So basically, once this step actually involves putting the task into the timeline and assigning them different priorities and assigning them the start and the end dates. And you need to identify the bottlenecks, the tasks which are needed to be completed before completing some other tasks. And again, a Gantt chart is basically will help you to visualize your project timeline, and it will help to identify the potential obstacles. So you need to list all the task owners, timeframes, and dependency in this software. So now at last, you need to share the project timeline. And here you need to communicate the final project timeline to the stakeholders and the team members to make it sure that each and every member has the clear understanding of the priorities and their responsibilities, and also the deadlines of the different tasks which are chosen by you. So now here is a demo of the timeline document. So this is the timeline document. So this is the front page. So this is my index page. So yeah, user can jump to any particular part of the document by reading this index table. So this is the introduction part. Here I've given the overview of my web application, of what the web application is actually about its what it actually does, it different features of like how a user can analyze a particular stock and make informed investing decisions. Then I have discussed the purpose and the goals of the project, and afterwards I have also here displayed the key stakeholders like the individual investors, active traders, or the financial advisors, or the institutional investors, or the financial journalist, all those who will be benefited by our website. I've listed those. And then I have then written the project scopes and deliverables. So these are the scopes and features of the project, like the real-time data updates of the stocks and the user-friendly interface. Also, one can search and analyze stocks, and also the relevant news articles about the stocks, and a secure user authentication, as it will store user information and its stock information. So it need to have a secure user authentication. And then the scalability and the reliability aspect of our website. Also, now I have written the main deliverables of the project. So first is the source code, the complete source code containing the backend as well as the front end. So it will be the one of the deliverable. And then the charting and the data visualization, which is one of our important features of our website. So it will help user to analyze the performance of individual stocks and broader trends. So it is also important deliverable. And also the news and analysis integration is another deliverable. And also the real-time stock market data, which is the crux of our website. It is one of the deliverable. And at last, the user documentation, which will help the user to use the web app, and it will include any necessary setup or configuration steps. And then the project timeline. So here I have listed the phases and the key milestone. So first and foremost is the planning and the requirement phase, in which you will identify the scope and objective of your project and identify the target audience. And then the design phase, it will actually involve writing wireframes and mockups, and it will basically involve setting up a basic file structure. And then the front end development phase. So basically you will be developing a front end using CSS and SCSS and to create a responsive design. And also you will be implementing the user authentication using JSON web tokens and using password.js. And also I have written about the APIs, Alpha Vantage and News API, that will be used for display data in real time. And then comes the testing and the debugging phase. So Zest and Enzyme will be used for testing this website. And then the backend development phase. So it will involve writing the backend part using the Node.js and Express.js, and also creating APIs to handle user authentication and data retrieval. And then integration of the front end and the backend. And then at last, optimization of the code using techniques like code splitting or lazy loading. And then finally, deployment phase, and it will be deployed in Heroku or AWS. So these are all the phases and milestone of our projects. This is the timeline. I'll show you on Jira website. So you can see these are all the, in the left hand side, you can see these are all the subtasks. So these expand over a period of 2 months. So these, you can see the waterfall model I have created, and you can see these arrow represent the dependencies, like this green one, or like it is the styling of the applications. So for doing the styling of application, you need to complete the previous two steps. That is, you need to do a basic setup. You need to learn about the React and do the basic setup and establish a file structure in order to do the styling of application. So like this, these are the arrows represent the dependencies, and these are all the tasks spanning over a period of 2 months. So this is one of the tasks, like introduction to React.js, and these are all the subtasks inside this for this week, I would say, like the read the documentation of the React and learn about React.js, and then setting the development environment. And it further includes another subtask of installing Node.js and installing the Node.js and creating a new React.js application using React app and setting up the basic file structure. So like these are all the subtasks that will tasks that are necessary for the completion of the project, and they are all included in the timeline. Also, these tasks within these tasks contains a different subtask that actually tells what you need to do for the particular task. So these are all the tasks, and in the right side, this is the waterfall style Gantt chart. You can see these, it also here, these are the starting or the end points of different tasks. Like you can see it starts from 7 July until 18 July until 21 July. So these are basically represent the time frame in which the task will be completed. So it spans over a period of 2 months. So like this. So it is this software is Jira software, and you can see here, you can like tag a particular task as in progress, or you can also tag it as a done process. So like this, you can also assign responsibilities. You can share this task with someone. So these are all the features of this Jira software. Okay, so this is all about the demo of the project timeline in Jira. So let's move back to documentation. So now I have also define the dependencies and critical paths. So one of the critical paths is setting up the development environment in React.js. So this phase is important as this phase sets up the foundation for the development of application, and any delays or issue in this phase can have a significant impact on the rest of the project. And another critical path is pulling data from the APIs and displaying data on the front end. So it is also the main focus of the one of the main focus of our project, and it involves the core functionality of this web app, and any delays in this phase can significantly delay the project timeline. So another critical path is implementing data visualization and integrating the news API. So these features are important for enhancing the user application. So basically, any delays in this phase will impact the project timeline, as this feature provide more value to the users. So this is also has been included by me as a critical path. So then comes the risk management. So what are the potential risks? So like the data quality and reliability. So this is one of the potential risks. So if the data source is unreliable and the data quality is poor, it will severely impact the information displayed in the app and lead to user mistrust. And another is the security vulnerabilities. So as it includes user information and the stock information of theirs, so it may lead to data breaches, and it can lead to loss of user trust. So this is one of the potential risk. And then comes the technical difficulties. So basically, our project involves various third-party APIs. So technical difficulties such as system crashes, data corruption, or API failures could be cause error in our development process. And another is user adoption. So even if you have completely designed the website, if the user interface is not good, then the user will not be happy and they may not adopt our website. So it is one of the risk. So what are the risk mitigation strategies and plans? So first and foremost is data quality and reliability. So let me connect my charger. Okay. So first is data quality and reliability. So testing the data sources and implementing a system to handle those errors and will be very important to ensure that data is reliable and ensure the quality of the data. And to ensure the security, you can use different protocols such as SSL encryption and or two-factor authentication. And you can also secure the databases which are being used by you. And then uh, for tackling the technical difficulties, you can use reliable APIs like used by us, like the Alpha Vantage API or the News API. So that will tackle the technical difficulties. And for the user adoption, user testing can be done and feedback can be taken from the users. And tutorial support to help the users navigate the app and its features can be provided to tackle to increase the user adoption for our app. And then this is the quality plan. So we can do regular code reviews to ensure that the code is written well and it is easy to manage. And then automated testing can be done using REST and enzyme, and continuous integration tools such as Jenkins or Travis CI will be used. So basically these tools will automatically run the test on any update made to the code, and it will automate our work. And then user acceptance testing can be done, and it will be done on a representative sample of users to test the application for usability, functionality, or user experience. So basically the feedback will be collected and it will be used to improve the application. So this is what user acceptance testing is. And then the security testing will be done. So it can be done using tools such as OWASP Zap or the burp site. And security testing will help to ensure that application is secure and that user data is protected. And then the performance testing will be done using tools such as Apache JMeter or Load Runner. And it will be used to simulate high traffic and test the application performance under high load. So it will help us to ensure that our system does not crash during high load conditions. And then the testing procedures and the accepting criteria. So unit testing will be done on the React components using Zest and Enzyme, and it will be done to test the rendering of each component and determine the expected behavior of each component. And then integration testing will be done to ensure that different components and application work seamlessly. And it will be again done by Zest and Enzyme, and it will be done to test the user authentication and data retrieval from APIs. And then the snapshot testing. So snapshot testing will be done to ensure that application's UI remains constant on with each update, and it will ensure that each component renders consistently with each update. So this is all about snapshot testing. And then at last end-to-end testing to ensure that entire application works as expected. So the acceptance criteria will be that all the unit tested should pass without errors, and the integration test should also pass without errors, and the snapshot test should pass without errors, and the UI should remain consistent with each update. It should not change. So then the communication plan. So all the communication will take place through email, and Jira app will also be used for communication and collaborating and issue tracking. So basically, it will be used to assign tasks and check the task progress and communicate with team members. Also, weekly meetings will be done through Google Meet, and progress report will be taken in those meetings also. And then project status reporting and updates. So weekly status reports will have to be submitted to the project manager, outlining the progress report made during the week, and also the challenges faced, and what will be the plans for the upcoming week. And any change request to the project scope or the timeline will have to be communicated to the stakeholders by emails, and will be discussed by weekly meeting before they are actually implemented. And the issue tracking will also be done through the Jira app, and status of these issues will be updated regularly and communicated to the stakeholders as necessary. So this is all about the project status reporting. And then the deployment plan. So it will be deployed on a cloud platform such as Heroku or AWS. And the build process, like a continuous automated development tool such as the Jenkins or Circle CI will be used to automate the build process, and it will automatically run the test on update. And the staging environment, which will be the exact replica of the production environment, will be used to test the new features and changes before they are actually deployed. And then the optimizing the performance. For optimizing, you will use techniques such as code splitting or the lazy loading. and these technique will improve the application loading speed and reduce the amount of data transfer within the front end and the back end. And then finally, the site will be deployed in the production environment, and it will configure to the it will be configured to use load balancers and auto scaling groups to ensure it can handle high traffic and remain available even in server failure. Okay, then the rollback plan. It is very important to have a rollback plan in case of any issues or errors in the production environment. So it will basically involve reverting back to the previous version of the application and investing the cause of the issue. So it was all about the deployment strategy. And these are all the references I've used, like the Upstart website to know about the research about the project timeline. And this is one of the YouTube video which I used to develop this timeline. And these are some other tutorials. This is the tutorial to use the Jira software from that Atlassian website. And this I have written out the conclusion. So this is all about the demo of my document. So now the challenge is faced. So first and foremost challenge was gathering accurate and comprehensive information. So basically creating a timeline document can be a challenging task, especially if you are dealing with a complex project. So to ensure that information is accurate and up to date and comprehensive, that was a challenge. And you need to do extensive research and analyze various sources, and such as historical documents or project plans and the stakeholder inputs. So this was one of the challenge. And another challenge was organizing the information. So basically, you need to organize the information in a logical and a meaningful way, and you may need to categorize the information based upon its phases and the milestone dependencies, bottlenecks. So you need to take care of all these things, and then you need to ensure that timeline document is structured in a clear and a concise manner. So it was one of a challenge. And another challenge was determining the appropriate timeline format. So basically, you need to there are different formats for representing a timeline, such as Gantt charts, tables or diagrams or Excel sheets. So your format will depend upon the nature of the project or event and the intended audience. So you need to consider the level of the details you need to put in your timeline and the timeline duration and the visualization requirements you have. And accordingly, you need to choose a timeline format. So choosing this format is also a challenge. And handling the dependencies and constraints is another challenge. For example, a task may need to be completed before another task can start, or a resource may be limited, causing delays. So you need to ensure that the timeline reflects these constraints accurately, and that any changes to the timeline do not violate any constraints. So these are all the challenges. And then the conclusion part. So basically, a timeline document is a very powerful tool to visualize the sequence of events that are being divided from the projects. And it will basically provide you a clear and a concise overview of the timeline, and it will facilitate effective communication with the stakeholders. So basically, creating a timeline document can be a challenging task that requires careful planning. But by following best practices and investing time and effort in creating a high quality timeline document, we can ensure that our project or event stays on track and achieve its goal. So to overcome these challenges, it is important to use the right tools and techniques and strategies. So this was all about the conclusion. So these are the bunch of references I have used. So this is for developing that timeline of document, and this is a tutorial for the Jira website, and this is one of the video for researching about the making a timeline document, and this is another blog from Lucid Chart on building a project management timeline. So thank you everyone, and if you have any questions, please go ahead.
I hope your presentation is done.
Yes, sir.
Okay, can you show me the Jira timeline that you create?
Okay, sir. So this is
Yeah.
the timeline.
Start from the beginning. Can you zoom in and show to me? Can you go in full screen? I believe you can press F11 and go in full screen. Okay, no issues. You can start
Yes,
the start of the time. Scroll up and show.
so what you need to see this starting part.
Yeah. Okay. Scroll down. Keep scrolling. Show me for the creating APIs.
Yes, sir. This is the part.
Show me what you have written in the tool.
So you need to create the APIs to handle user authentication and retrieve data from the database and for the data manipulation.
Gonna scroll down. In the
This much only.
in the to do create API to do. So what is the
What is it?
description of the create API to handle user? You have opened the to do for the
Okay, sir. Description I have not written, just this headline I have written.
Okay, sure, no issues. See, the thing is, not many people have actually performed this task clearly, but you have done this task really well. Okay, you have created a proper documentation as well as you have followed the proper rules of creating a timeline, that is using a professional levels software such as Jira. Okay, so well done on that one, but I believe you need to work on your overall presentation delivery, because when you have this quality of content, you have to keep up with your expression skills also. Okay, I believe
Okay, sir.
at the start was good. Okay, in the start you were going really well. Okay, but as you move on after the Zira, you basically started reading from the document at one point. Okay, but at the end you came back on the track. But overall delivery can be improved. Okay, overall formatting can also be improved, because see, you have great content, but I believe in the Jira software itself, all the steps that you have, you basically skipped them. You explained how to use Jira, like how to create a to-do list and everything, but actual task, you didn't really explain that part in the Jira software itself. And that was main task, that is to create a timeline. So you rushed it. So you should have given more emphasis on the Jira timeline itself. Other than that, see, your PPT was great as well as the documentation is great. But again, as I said, important information that is included in the expression should be included in the PPT, and documentation should be there for a quick summary, right? So you have already explained everything in the PPT. Now just give a quick summary in the document. That's it. So work on your overall delivery, I would say. Okay, the content that you have is really well done. The task you have performed is great. I would say it is one of the best tasks I have seen for this particular project timeline. Okay, so well done on the demonstration. Okay, just work on your delivery part. Other than that, you are going really good. Right?
Thank you, sir.
Yeah, thank you, Aakash. So we'll move on to his next person, Prithvi Poojari.
Am I audible, sir?
Yeah, you are audible. Please turn your camera. Tell
Sir,
me.
just give me 1 minute. I'll just set up the data IQ properly.
Yeah, sure. No issues.
Yeah. Yes, sir. Am I audible?
Yeah, you're audible. You can turn your camera on and share the screen.
Am I visible?
Yeah.
Okay. Just give me 1 minute. Is my screen visible, sir?
Yeah, it is visible.
It is visible. Okay. So hello everyone. I have been allotted the task of developing a future location prediction system. My name is Prithvi Poojari, and I am from SIS Graduate School of Technology. I'll be entering my final year. So here are the contents of my presentation. So first we'll be going through the task introduction. After that, I'll be giving an overview of the project before we actually dive into the workflow. Then we have the users, and then we have the actual project workflow. Then we have the final evaluation or the result, and conclusion and Q&A. So here's the task introduction. I was assigned to develop a future location prediction system using Data which is a data science studio or a tool, which I'll explain further. I was asked to set up Data on an EC2 instance, which is like a Linux server on a cloud. And using the provided data set and tools like Data I was asked to create a model, analyze the data, and then visualize the data. I'll be speaking about Data first. So Data just like I mentioned, it is a data science studio that provides an integrated platform for data science and analytics. It offers a collaborative environment where data scientists or developers can analyze a particular set of data, and then they can visualize that data in the form of a flowchart. I have mentioned like a few key features of Data and I'll talk about it briefly. So the first one is data integration. Data allows its users to connect various data sources such as databases or cloud storage and multiple sources of data. It also provides tools for data preparation, cleansing, and transformation. Next up, we have visual data exploration, which is one of the major features of Data and I have shared a snippet of the workflow further in the slides. Then we have machine learning algorithms. Now, Data being a data science studio provides multiple machine learning algorithms such as random tree forest, deep neural network, KNN, CNN, XGBoost, and lasso large regression. Then, just like I mentioned initially, there is collaboration. Now, Data promotes collaboration between different kind of stakeholders involved in data projects, and it offers features for sharing and like documenting all of the analysis. Then I've also mentioned governance and security. Now, since we hosted Data on Amazon Web Services, I was directly given access to the admin roles. Being an admin, I can give other developers access to certain feature handlings and algorithms so that they can create their own sort of analysis. Then we have Amazon Web Services. Now, using Amazon Web Services, we hosted Data Now, it is like a cloud computing platform, and which is provided by Amazon, and it offers like a wide range of cloud services, computing power, storage, databases, networking, machine learning. Of course, we could have used Data by installing it on our system, but the thing with cloud is that it can give us high computational powers right across the internet, and it makes everything easy, and our time is also saved if we are to do different sorts of analysis on our data. So the key components, just like we all know, compute services, which I did mention right now. There is storage and content delivery. We can there are options to store different kinds of data. And yeah, that's for storage and content delivery. For databases, yeah, it does provide different sort of databases such as Amazon RDS. Now RDS stands for relational databases. Then we have DynamoDB. This is for NoSQL databases, and Amazon Redshift for data warehousing. These services are simply basic database administration tools. Then we have networking, of course, since it is a cloud-based web service. Naturally, there can be various tools and protocols that can be created for networking between users and developers. Then, just like I mentioned initially, Amazon Web Services also provides us with machine learning and artificial intelligence algorithms. Now, overview of the entire project. So if we look at the data set that is provided to us, there was, I'll show the data set later, but we have to create a future location prediction system, right? So for that, we will have to need some sort of a data set that can analyze all sorts of past patterns, such as the latitude start or the longitude start, so that we can predict latitude ending values and the longitude ending values. Now, I have also mentioned here that the target variables include geographic coordinates, which just basically means that we are targeting the latitude end value and the longitude end value, or the destination values. Now, there are multiple sort of techniques which can be used for the prediction. First, we have the time series forecasting. Now, this includes our lasso large regression and our XGBoost regression model. It also includes a ARIMA model. There are multiple models over here. Then we have machine learning algorithms and spatial techniques such as spatial interpolation. Now, the past data contains enough relevant data to make further predictions. So just like I mentioned initially while starting off with the slide, lasso large regression is used for latitude, and the XGBoost is used for longitude. Now, I'll be talking about the features of how we can actually use this future location prediction system. So the first one, just like I've mentioned over here, is logistics and transportation. Now, future location prediction systems can be valuable in optimizing transportation and logistic operations by predicting the future location of vehicles or shipments, and by which companies can actually optimize different sort of routes and save time. Then we have urban planning and infrastructure. Now, predicting future location patterns can sort of aid urban planners in making informed decisions regarding infrastructure development, public transportation planning, and city layout. Now, by analyzing these huge population movements and by predicting these future population distributions across like a particular state, we can make city planners based on these prediction systems, and this can sort of optimize resources, and we can also further plan new infrastructure projects. Then we have retail and marketing. Pretty much the same. This can assist retailers and marketers in making data-driven decisions regarding their new store locations, marketing campaigns, or by customer targeting, and usually by targeting metropolitan cities, and by also analyzing past historical location data, and by predicting future movements of the population, just like I said before. Then we have personalized recommendation. Now, future location predictions can be great if, let's say, we have we record behaviors and movements of a user, and the places that he or she ends up visiting. And what we can do is that based on all of the locations that they have visited, we can sort of bring up this recommendation system of new places that are similar to the data that we have recorded, and provide them that. Then we have safety and security. Now, naturally, this can be actually very valuable for security applications. For example, when it comes to like public safety scenarios, predicting the future location of emergencies or crime incidents can sort of help optimize emergency response efforts and allocate resources efficiently, be it from deploying certain task force to a particular crime scene as efficiently as possible, and also to set up certain task force squads in particular areas where the crime is way more than the bar. Then we have healthcare and elderly care. Now, future location prediction can be beneficial in healthcare settings. Similarly, for it can be like for remote patient monitoring and elderly care. For example, we can get the data of most of the elder people staying in certain areas of the city, and and using that data, we can actually end up uh, building hospitals so that we can immediately provide healthcare and elderly care in case there is an emergency. Now, here's like a simple flow of how the project is going to operate. So first, what we have done is that we have collected and imported the relevant data set that was provided by Hackveda to us. Then we have to understand the required features of that data set. So in this data set, we have our event start time, we have our event end time, we have latitude start, we have longitude start, and we also have been provided with longitude and latitude ending values as well, so that we can further predict new values. Oh, also, I'll just complete the steps. We have quality check, and then we have model building and analysis. And after everything has been set and put into place, we can then analyze the values, and we can choose a particular algorithm that provides us with the best accuracy. Now, here is the data set. So just like I mentioned, we have the event time start, we have the event time end, we have the latitude start, we have the longitude start, we have the latitude end, and we have the longitude end. So initially what we'll do is that we'll first take the latitude start values, we'll take the event time start, and then we'll take the event time end. And using that, we will, and we'll also use the we'll also use the longitude start, and using that, we will then predict the latitude end values using lasso-Larsen regression. And similarly, we will then do the same for longitude end using XGB boost. So before I dig deeper into all of this, deeper in the sense, deeper in technical terms, before doing that, I would rather just start off with this story to give everyone present here a simple understanding of what lasso regression actually means. Now, imagine we sort of have multiple items, and we want to choose which ones are sort of important to us. This sort of usually happens when we are maybe shifting to a new place, and and when we do that, we actually do want to get rid of certain sort of items. So here we can think about lasso regression as this tool that will help us decide which items are best for us and which items are worth discarding as well. Now, let's just say the tool, this particular tool that we have, it sort of gives each of items a number based on how important it is to us. And higher the number, the more important that item becomes naturally. But here's a catch to this entire thing. The tool also sort of wants to make things simple for us, and it also wants to make things neat for us. So we are only allowed to keep like a certain number of what do you say? Yeah, items. So what lasso regression ends up doing is that it gives each item this special score, and if that toy is very important to us, it gets like a very big score, right? And if that toy or like item is not that important, it gets like a smaller score. Now, some items, just like I said, if we want to really discard them off, we give them 0 value, and this means that they're not important at all. So what this tool does is that by looking at how all of these items relate to each other and how it relates to us, it gives all of these items it checks first and sees if we can replace these items by other present items as well. And by doing this, the tool sort of figures out which one is truly important to us, and which ones we can discard and which we can live without in our new place. Now that I've explained sort of all of this in like simple terms, I'll dig deeper. So lasso Lars, uh, regression is like a variation of lasso regression, and it combines the lasso penalty system. Just like we said, we have to discard certain things. So lasso penalty is there with the Lars algorithm as well for efficient computation. Now it is used for feature selection and regularization in linear regression models. Now, since it is a regression model, and since to predict the latitude in the first place, what we have actually done is that we have selected certain features. Like we did not end up selecting the latitude end value and the longitude end value to predict the latitude end value. Then Lasso Lars usually ends up performing this L1 regularization, which is similar to the lasso regression. And this happens by adding the absolute values of the coefficients multiplied by a regularization parameter. And this regularization parameter in this case would be lambda or alpha, which we will see in the screenshots that I've attached further ahead. Now, the Lars algorithm sort of incrementally adds these different predictors to our models, and at each step, it sort of identifies the variable that has the most positive correlation with the response variable. So in this case, naturally, all the variables that we have selected, be it from the event time, event time start, event time end, all of that. So it is particular. So just like I mentioned, it is useful when the number of predictors is large relative to the number of observations. We need the predictors to be extremely large in value when it comes to the key number of observations. Then it is just best suited for when there are like correlated predictors, and it tends to handle all of the cases stably more than standard lasso regression. I've mentioned a few points over here about lasso regression, which aren't really that important, but to give like a simple explanation, I've just kept it here. So I explained lasso Lars regression. Lars actually stands for least angle regression. So this is the snippet. Now, if we do observe, our R2 score is actually 1, which is great, but it also indicates that there is overfitting. And if we look at the lat start over here, it shows it's completely accurate. It's around 99%. Then comes up XG boost. Okay, so just like I explained lasso Lars regression, I will then explain XG boost. So let's say we sort of have multiple pieces, and we multiple pieces in the sense that, let's say we want to create a puzzle. So XG boost is sort of having this special power to put all the pieces together so that we can just finish the puzzle. Now with XG boost, what happens is that we can look at one puzzle piece at a time, and we sort of need to understand what piece looks like and where it might fit in the picture. We do this for each piece one by one. So what happens next is that XG boost will also sort of learn from our mistakes, and by learning from our mistakes, it will just see if we place one piece in the wrong spot, and then XG boost sort of will tell us that what went wrong, and we can actually what we can actually do to fix it. It will end up giving us hints to try a different shape, or look for a similar pattern or a similar color, so that we can just complete the puzzle. And it can help us eventually make better guesses by trial and error. So as we keep working, XGBoost sort of helps us to pay attention to all of these important details, and it then ends up noticing these things like the shapes, the colors, the patterns, by making mistakes and by making the right guesses. And it then helps us understand which pieces need more importance and more extra attention. And with this superpower of XGBoost, we can solve the puzzle pretty fast, and it helps us complete the entire thing, right? It also helps us to find right pieces, and it sort of guides us along the way so that we can create the best possible puzzle as soon as possible. So I'll just come to the technical terms now. Now, XGBoost it is a popular machine learning algorithm, and it belongs to this gradient boosting family, and it was designed to handle like a variety of regression and classification problems. Now, XGBoost builds an ensemble. Now, ensemble technique is like one of the methods which is commonly used in machine learning algorithms. So we built like an ensemble of all the weak prediction models, and this is typically done in the form of decision trees. And just like I mentioned before, while explaining it in layman terms, we build this weak prediction models by making the wrong guesses, or like guesses that might potentially end up being wrong. And then we use the gradient boosting framework that is inbuilt in here, which then minimizes the loss function by sort of iteratively adding these models which are correct, which have learned from the previous mistakes. And the entire concept of like XGBoost is to just come up with a new model by learning from our previous mistakes, and to fit this new model to like uh, to like the previous residuals. And residuals are sort of the actual and like the predicted values of the previous models. And just like lasso lars, this also incorporates regularization techniques to prevent overfitting and improve generalization. It also uses L1, which lasso lars regression uses, and it also uses L2 regularization to control the complexity of the model, and to sort of prevent excessive overfitting, and to prevent excessive emphasis on the individual features, so that we can analyze other potential guesses or other potential features of the data set quite fast. It Since we also mentioned gradient boosting framework, there is gradient boosting with column sampling or feature sampling. This is also done to reduce overfitting, and it is also done to improve the model's accuracy, the robustness, and everything. Then I think that is pretty much it. We all know the basics of this. It like every model, it provides flexibility in hyper tuning, and it has like sort of gained popularity, which we will see in the further in like the further slides. And it has sort of resulted in being used in pretty much every prediction system in the real world as well. Now, yeah, so this was pretty much about XGBoost. Just like we had seen for latitude, the lasso last regression ended up giving us like an R2 score of 1. XGBoost also did the same thing for us. It gave the value as 1. Clearly, longitude end was predicted using this. Now here's like the workflow. So we started off with providing a location data set, which was provided to us by Hackweather. We trained the data set in like the 80 to 20% rule. Then we created the prediction of the destination latitude using lasso lars regression. We then ended up creating a metric for it, so that we can actually understand what exactly is happening. Is it accurate enough to give us the proper the proper predictions? Then after that, we created a new data set that actually predicted the latitude. And from that data set, we ended up predicting the longitude values, the longitude end value in this case, using XGBoost. And after that, we were, like I showed in the XGBoost screenshot as well, we were given like the R2 score was 1, which also shows that it is very well built, and no other algorithm can outbeat that. If you see over here in the upper flow, I have actually used KNN. There are multiple algorithms that is provided to us by data IQ. So I couldn't do all of that, but I have taken the example of KNN, and it turned out that KNN gave us an accuracy of around 58%, which is very low, which means that it is just unreliable to use it to predict latitude and longitude values. Now, here's the key observation. So when it comes to latitude metrics, we can see like the efficiency is 99%, and the Pearson score, which is very important to determine if we can actually use this, it is 99% as well. This is for Lasso-Lars regression. Now, when it comes to the XG boost, and we did this for longitude end values, the efficiency is 99%, and just like Lasso-Lars, the prediction value is the Pearson value is 99%. The R2 score is also 99. Now this is like the, what do you say, the screenshot of KNN. As we can see, it's mentioned here that it is 89%. The precision is around 41, and yeah, this just says that we can't use it. Pretty much every single algorithm apart from Lasso-Lars regression or XG boost gave us like this, gave us this accuracy of around 58%, which is very low. And I'm talking about not just specific values, I'm actually talking about the overall calculated values of each of these columns mentioned over here. I'll just show the demonstration of the project. Sir, my tab is visible, right?
Yeah, it is visible.
Okay. Okay. Here is the location data set. Now we can see we have ID. ID is not actually necessary. It's just for labeling purposes. We have the event time start. We have the time end. We have the latitude start. We have the longitude start. We have the latitude end, and we have the longitude end. We have used all of these values. Now we can see here that the training ratio is 0.8, which just basically means that 80% of the data is trained, 20% is tested. Then we have the prediction of the destination latitude. Here are all of the scores mentioned, and if we can see the metrics and assertion, we have like the explained variance score is 1, which is like the R2 score, obviously it is 1. Pearson coefficient, it resulted to 99%, rounded off to when we round it off, it becomes 1. Once we did end up having a model ready with us, we predicted the latitude data set. And what has happened here is that here we have this new prediction column. And if we notice, the latitude start and the prediction column values are very, very similar. It's 38.77 over here, it's 38.78 over here, it's 47.40, it's 47.42. So we can just say that it's very close. The prediction values are very close. And using this this new data set where we created a new column to show the predicted values, we implemented the XG boost algorithm to create a new model that would further create a final longitude value. This is the XG boost overall score that I had included in the presentation as well. Here is the metrics and assertion. It's the same thing. R2 score is 1. Pearson coefficient is 1. And this is like the final output. Excuse me. Yeah. So as we can see, we have the latitude start, we have the longitude start, we have the latitude end, we have the longitude end. The error is extremely low when it comes to this. And here is the prediction of the longitude end. You can see the scores are very similar, very, very similar and very close. It's minus 9.09 over here, it's minus 9.08 over here, it's 47.42, it's 8.5. Oh, my bad. It's 8.55 over here, it's 8.554. It's very close. For the sake of comparison, I did use the K nearest neighbor. Data IQ had some sort of an issue to give me specific metric values. but as we can see, the score over here is 0.5, and which is low, which is low. We just can't use this. And if we compare it with the lasso large regression, and if we compare it with the XG boost, the scores are just 1, and that is what we need. I'll just see if I can show the metrics. No, okay, I can't show the metrics. Yeah. This is pretty much it. Somehow there was some sort of an issue to compile all of the libraries, and I actually wanted to show the comparison using deep neural networks, but certain Python libraries had issues over here, so I couldn't thoroughly show it to you guys. So yeah, that is pretty much it. And here's the conclusion slide. So by the end, we were just able to come to the conclusion that we can build a future location prediction system, and for that to happen, we used the lasso large regression, or the L1 regression for the latitude. We then used XG boost for the longitude, and using these two particular algorithms, we can actually create multiple systems in real time when it comes to giving predictions or making recommendations to users. Thank you. If any of you have any questions, please go for it.
Okay, so I hope your presentation is done.
Yes, sir, it's
Okay.
should I stop sharing?
No, sure.
Okay.
No.
Yes.
See, well done on the presentation. Okay, your explanation skills and you were giving examples on some complex topics. That was a good thing. But I would recommend you to work on your presentation start. Right. So how you start a presentation. So you have two scenarios where you know what you need to do, but you don't have a data set. Okay. Or second is you know what you need to do and you already have a data set. Right.
Okay.
See,
right.
Those two things are different, but the way you will execute your task is also different. In
Right.
a scenario where you don't have data set, but you know what you know to do, you have liberty of choosing what kind of data you want to collect, what kind of data is necessary,
Right.
how well we can perform the task if we have the necessary data. So
Right.
you already have a data set, but you have a task, and then you need to decide how you need to complete it with the possible data, or if you need some extra data.
Right.
So second thing is your task belong to the letter where you have a data set and you know what you need to do.
Yeah, exactly.
Important that you start by giving some exposure on what is future location, like some context, simple context, let us say how you are going to execute it on a higher level. Say you are going to use longitude, longitude, and other coordinates, as well as the timing, right? These are
Right.
important features that are in your data set.
Right.
You can move on to explain how it is working, because we talked about how you are using the coordinates to perform certain things, but the data set was not explained at the start. So things were not really in the place together. But after the start part was there, in the middle part to end part, your explanation was on point. It was great. You did give proper examples, which is, I really like those examples, I would say. Right. But your overall, I would say the delivery needs to be improved.
Okay,
also, it is good thing, a good practice to start your introduction with your actual self introduction instead of task introduction. Okay.
Okay.
Practice on that. See, what you can do is, I would recommend, see, you have a good presentation skills. Okay. What you can do is you can create a pitch deck or a script that you want to say, and then you can practice it and then deliver the presentation.
Right.
Will enhance your overall presentation skills.
Right. Right.
Second thing is, in the task itself, you were saying that your prediction scores were really close, right? Really extremely close. I think the difference was 0.01%.
Yeah, something around that.
So can you tell me why do you think that happened? Was it because there are only two scenarios, right? So either you have done a really great job. So I would say congratulations on that you have done a really great job. Other is either there was some problem with the data set, right? So what do you think may be the issue?
Sir, like if we do talk about the data set that has been provided to us, I believe like since I feel like the entire agenda or the objective of even providing us with this project was to just explain how lasso lasso regression works and how XGBoost really works. Now, obviously, in real time, the difference, when it comes to precision, it would be extremely high. But for the sake of understanding, for the sake of how well these algorithms can actually work, I believe that the data set did have values that could be easily predicted by these algorithms, but they could not really be predicted by other algorithms, which I did notice. Like the differences were extremely high. So even if we do end up implementing the other algorithms to create like a prediction system just like this, it would sort of, give it would just fail in real world. Just like I said, the difference would be extremely high.
Okay, see, the thing is, you are right and also wrong. Okay, the right is because we like did give you this task to understand like various algorithms regression.
Right.
You have done a good job on that, but when it comes to like you're doing it on a real world data,
Okay.
these algorithms do work. Okay, but you have to fine tune your models. Second thing is you have to like in data IQ itself, you can like get uh basic analysis of data set when you upload it. I would
Right.
you to look at it, you will realize what the issue is.
Right.
So I can give you a hint that data is like too much biased. There is
Okay.
biasness in the database. So because
Mm.
of that, like we are getting something. So
Right. Right.
do the research on that. Okay. In the
Sure, sir.
IQ itself, you will realize there are a lot of things that are automated and you can get a lot of information. So I
Right.
would recommend to do that and do some more in-depth research. You will
Sure,
realize,
sir.
what are the insights of your data.
Sure.
Okay.
Mm.
So
Okay.
perform that. Other than that, I would say it was a great explanation. Okay. But
Thank you, sir.
you please focus more on like the outputs that you are getting. I mean,
Okay, sir.
they were quite rushed. You didn't like explain the outputs clearly. So
Yeah.
and
Yeah.
I want you to focus on that.
Okay, sir. No problem. Thank you, sir. Yeah.
Okay, so we'll move on to Vinoothna. Vinoothna.
Good evening, sir. Am I audible to you?
Yeah, you are audible. Can you tell me your task name and please turn your camera?
Yes, sir. Prescriptive analysis, sir.
Okay, you are scheduled. You can share the screen and start.
Yes, sir. Is my screen visible, sir?
Yeah, it is visible.
Good evening, everyone. I am Y.Vinoothna and I am from Machine Learning Group. And today my presentation is regarding prescriptive analysis. So let us take a look on what is meant by prescriptive analysis. So prescriptive analytics works with another type of data analysis which involves the use of statistics and modeling to determine the future performance based on the current and historical data. So by using prescriptive analysis, we are going to forecast the future performance of our ML model or future performance of the demand and such etc. For example, some company produces some products and many orders will be received by that company. So before taking any precious decisions, how to import, when to import the product and when to transport the product to the respective places. So it has to do some analysis. So the companies will do some analysis. So before taking any decisions on preparing such products. So in such manners, in those situations, this prescriptive analysis will be useful. So this analysis is useful in financial and business, so to forecast their profit in future and how their product will go on in future. So based on the current and historical data they have recorded. So now for this task, I was provided with data set historical product demand, which contains 5 columns and 10 lakhs 48,575 rows, which is a very large data set. And the columns are provided here are product code, warehouse, category, date, and order demand. Now, product code represents the code of a particular product given by such manufacturing company, and warehouse means the names of warehouses where the product is stored and from where the product will be shipped to the appropriate place. And category represents the type of product, and date represents on which date the order has been shipped or on which date it has been received. An order demand means it represents the demand of the product in terms of how many orders particular product has received. And now my task is to prescribe the order demand. I mean, I have to forecast the demand in future years. So based on the current historical data given in the dataset historical product demand. Now, so my approach to this task, so I have followed these steps in order to predict the future performance. I mean, future performance and future predict and future demand. So among these steps, the first step is data understanding. Now, before going to build any machine learning model, or before starting, so we need to understand the data. I mean, we have to get an initial idea about the data given in the data set. So for that sake, now here I have found the size of the dataset by using a shape. So now the shape of the dataset has 5 columns and 10 lakhs, 48,575 rows. So this is the size of the dataset. And we can find the unique values in each column. So here, for example, so I have found the unique values in the product code column. And these are the unique values that have been recorded in the product code column. So let us see it in a demonstration. So here I have used Google Colab Notebook.
Sorry, can you come again?
Sir, I have used Google Colab Notebook for the demonstration.
Okay, yeah, your collab notebook is visible.
Yes, okay. So here I have imported all the libraries that I have used. And now here I have loaded the dataset historical product demand dataset. And by using head method, I have shown the top 5 rows of the dataset. So here product code represents the code given by the manufacturing company to a particular product. And warehouse, these are the warehouse names. Product category, the category names are given here for each product, and date and order demand. Now, as a part of data understanding, so here we can understand by using the shape method that this dataset has these many rows and these many columns. And by using unique method, we can find number of unique values in each column. So here I have found the number of unique values in the product code column. So these are the unique values, and these are the values which are repeated in the data. And now we can find data type of each column by using D types. So here by using the D types method, so now all the features, nothing but all the columns are has the data type of object data type. Now here we have to observe is the order demand, as we have said already. The order demand represents the number of orders each product has received. But here in the dataset, the order demand is in the object data type. So we have to convert that data type into object data type into integer data type, as the order demand represents the number of orders, which means it is an integer value. So we have to convert this object data type into integer data type. So here I have I have created some function to convert the values in the order demand column into the integer values. So after converting into integer values, now the output is here. So it has, I have checked some by giving some value in the object data type, and it has converted to integer successfully. Now we can check again by using D types. So here the order demand data type, the order demand column has changed to integer data type. So we have understood that the data set has so and so columns and so and so rows with some unique values. Now, after understanding the data, after getting initial idea about the data set, now we have to clean the data, nothing but we have to prepare the data for building the machine learning model, so that when the data is appropriate, our machine learning models work better in predicting the future values and in predicting the target variable. Now, as a part of after the data understanding, now we have to clean the data. So we have to perform data cleaning. So here, as I have said now only, so I have converted the order demand column into integer data type. And again, we can get the statistical summary of the data set. So by using describe method, we can get the statistical summary, nothing but the mean, standard deviation, and count of the column order demand. As it is the only column of integer data type, so we have got the statistical summary of the order demand column only. And here we can see that the column names of the column names mentioned in the data set are very large. So this is an optional step. So we can change the column names into some simple names. So here I have used a rename function to change the column names to simple names. So I have changed the product code column name to code and product category to category and order demand to demand. So we can make the column names simple for our further procedure. And the most important step in the data cleaning is we have to find whether the dataset has any null values or not. Because if the dataset contains any null values, our machine learning model will not be able to may not be able to fit the data. So the accuracy may reduce when there are null values. So we have to find the null values and we have to handle those null values. So to find whether the dataset has null values or not, we can use isNull method so that we can find whether any column has any null values or not. Now by using isNull method, now here I am able to find that date column has some 11,000 to that 9 null values, nothing but some data is not recorded in the date column. So I have to handle this null data. Now we will see this in the demonstration. Yeah. So here by using describe method, I have got the statistical information about the order demand data set, order demand column. Now the order demand, I think, but the number of orders. So the mean of all the orders in the data set, and this is the standard deviation of all the orders, and this is the minimum number of orders, and the count, total number of orders. So this is the statistical information about the demand column. So here I have used rename function to rename the column values. So after renaming, the dataset has given the column names as code, warehouse, category, date, and demand, as I have given in the map here. So to find the null values, I have used isNull method. So from this method, we can find that code column has 0 null values, warehouse column has 0 null values, but the date column has 11,239 null values. So when we find the percentage of null values in the data set, so here it is given that only 1% of the data has only null values. So it is very less value. So we can remove those null values because those null values will have a less effect on the data. So by using drop null method, we will be dropping all the rows where there is no data in the date column. So after dropping all the null values, so here now the date column has 0 null values. So we have get rid of all the null values in the data set. And now we can find, now our data set has many here the data set provided is very large data set. So we have to make sure that from which date to which date the data has collected in the data set. So for that sake, we can use the minimum function and we can obtain the minimum and maximum, the starting value of the date and ending value of the time, in which time period the data has been collected. Now here it is given that from the data has collected between 2011 to 2017, from 8th January to 9th January. So the data has been collected between 6 years. Okay. So the data that is provided in the data set is collected for 6 years. And now as we have to predict the order demand in future years, now the main important feature is the date. The main important feature in the given data set is date. So we have to make the date column as the index column because as the demand here is dependent on the date, time. So we have to make the date column as the index column. So here I have made the date column as index column by using set index method. Yeah. So this is regarding the data cleaning. So we have removed all the null values. So we have found whether the data set has any null values, and we have removed those null values. So now we have prepared the data set for building the machine learning model. Now the next step in this task is univariate analysis. So we can perform some analysis on the features from the columns that we have in the data set. So univariate analysis means it is a process of analyzing only one feature of the data set. So here I have, so by now the univariate analysis can be can be performed by plotting the bar graphs. So here I have plotted bar graphs for the columns warehouse, category, and demand. So now by using Seaborn's count plot function. So here I have plotted bar plot for warehouse category, warehouse column. Now this is the picture that depicts the bar plot between warehouse and demand. Number of orders. So from this plot, we can say that the warehouse J has more orders than other warehouses. So it has nearly 77,50,000 orders. So now the warehouse J has significantly more orders than other warehouses. Now on plotting the bar plot for top 5 categories which are highly shipped from shipped from warehouses. So here I have plotted bar plot per category values. The top five categories values have been plotted in the graph. So here we can observe that category 019 has been shipped the most orders in the product category. These category products have been shipped more than others. And now coming to the target variable, which is the demands. Now on plotting the demands. So here I have plotted the line graph for the demand column. So the data is recorded from 2011 to 2017. So as we observe, the more data, some data between 2011 January to 2012 January has been missing here. So these missing data will be, the list data, these missing data will be can be removed for further improvisation. So I have removed the missing data from 2011 to 2012, and then the plot looks like this. Let us see. Yeah. So here the plot of warehouse column, where warehouse J has more number of orders. Okay. And here the top 5 categories of products which have been shipped more. Now here the category 019 product has been shipped more times. And now here the demand column. So here I have plotted that order demand column where there is some missing data between 2011 and 2012. So we will be removing those missing data. So that now our data is considered from 2011 to 2017. Then. So after performing a univariate analysis, we can also perform bivariate analysis. Nothing but we can check some relationship or some dependency between two features, two columns. So here I have analyzed two features, warehouse and demand, with its average values and real values. So here I have found the warehouse whose demand, I have grouped the warehouses and its respective demands, and I have plotted the graph. So here when I plotted the graph between the warehouse and their respective demands, warehouse J has more number of orders. But when I have plotted the graph between warehouse and warehouse and on average demand, warehouse C has more number of orders per average. So Here on conclusion from these graphs, warehouse J has the most orders, and warehouse C and warehouse S have shipped the most number of orders on per average. So this, this result can be helpful when we want to reduce the cost of operation and when we want to invest on the shipping, for the instance. Yeah, so that is about bivariate analysis. And now the next step we have to do is feature engineering. But we have to select the appropriate features useful for our building the machine, building ML model. Now, feature engineering is the process of converting raw observations into desired features using statistical and machine learning approaches. So now in the dataset, the most important column is the date, because the demand or the orders are more dependent on the time. So that's why we have taken the date column as the index value, and we have to extract the features from the date column. So here I have extracted the features like day of the week, quarter, month, year and week from the date column. So these features will be the appropriate features for our for predicting the target variable. So let's see. Yeah, this is the bivariate analysis that I have shown in the presentation. And yeah, so as the time is very important here in the data set. So here I have extracted the features from the date column, which are day of the week, quarter, month, year and week. So extra, 4 columns have been added to the data set. So here is the resultant data set after extracting the features. Now the appropriate features for the prediction are day of the week, quarter, month, year and week. And the target variable is the demand. At the moment, we have to predict the demand based on these features. Next step is building. Now we have done all the process, data cleaning and the preparation of feature engineering. So now we have to build the machine learning model by using XGBoost algorithm. So here, so to build it, we have to split the data set into training and testing data. So this is the plot that represents the training data, and the red plot here represents the testing data. So by creating the object for the XGBoost regressor, we can predict the demand values. So let us see that. So here, so I have split the data into training set and testing set. And this is the plot of training data and testing data. Yeah. So now here I have created an object for the XGBoost regressor, and I have predicted. So, and I have predicted the testing data. So we can check that the accuracy on prediction is very low, which is 0.04. So from this, we can observe that XGBoost was really bad in, in choosing, in finding the trend and seasonality in the data. So now, so as XGBoost algorithm failed in predicting the data, because as its accuracy is very low. So now we will improve our ML model by using some another technique called time series analysis, which is a robust machine learning technique. And by using time series analysis, we can find the trend and seasonality in the data set. Okay. Now, as the normal model has failed in observing the trend and seasonality, now we are further proceeding by using time series analysis. What is meant by time series analysis? So time series analysis is a specific way of analyzing the sequence of data points collected over an interval of time. So as our data, as our demand is more dependent on time, date, so which is time. So we use the time series analysis here. Now here if we plot, the demand values per weekly, this is the box plot which represents the demand values per week. So here we can observe that there are many same values. There are many same values of demand for many weeks. So we will be gathering all the demand. We will be resampling the data based on the weeks. So in the above plot, we can see that there are a lot of same demand values. So we can collect them on the basis, we can collect them on weekly basis. So we will be resampling the data on the weekly manner by using mean. Yeah. So we will be resampling the demand values on the basis of weeks. So nothing but for every week, we will be calculating the mean values of demand, and we will be storing the mean of demand in the starting date of the week. So this is what resampling means. So this is the resampling of data on the basis of week. And if we observe that, so here I have found the importance of each feature. So here the month feature, the month feature has more importance in this task, in the prediction of demand values. So we will be resampling the data on basis of monthly order also. Yeah. Now, so after resampling the demand values on the basis of weeks, I have plotted the demand values on weekly basis. So here we can observe that at the end of 2012 year, the demand has been increased very high, and at the January month of 2013, the demand has been decreased, and it is eventually changing. And at the end of the year, the demand has been raised. So we can see the seasonality at the end of the year. We can see the increment at the end of the year, and we can see some decrements at the starting of the year of next year. So this is the seasonality we can observe on the weekly basis. In a similar way, we can resample the data in monthly order also. So here I have done resampling on the basis of monthly. I have resampled the data based on monthly order. So after resampling the data, and I have plotted the monthly order demand here. So we can see there is some increase in the demand after the 2013 year. So we can see there is a sequential increase in the demand when we see it in the monthly order. Yeah. Is what I have said now. So here we can observe that there is some seasonal pattern when we plot the data on the weekly demand. So the demand has been increased at the end of the year here, and the demand has been decreased at the starting of the next year. That may be because of due to holiday season and other etc. So here I have resampled the data on the monthly basis also, because the month feature has more importance. So I have plotted the graph on monthly. I have resampled the data on monthly basis. So we can see that there is an upward trend in the data. So now we can check whether the time series is stationary or not. Nothing but we can decompose the data to check whether there is any trend and seasonality. Okay. So here I have used RC params library to decompose the data set to observe the trend and seasonality. So here when I decompose the data set, I have observed some trend and seasonality. So this represents the trend, and this represents the seasonality in the data set. So when the trend and seasonality have been observed after decomposition, then we can state that our data is not stationary. So when we apply any time series analysis, our data set should be stationary. So from this graph, we can observe that the data set is not stationary, and by using some add-fuller test also, we can state that whether our time series is stationary or not. Now, add-fuller test is also done to check whether the time series is stationary or not. So it will be, this add-fuller test is based on statistical values. So when we use add-fuller method here, so here we can check the p-value here. It is highlighted with if the p-value is less than the threshold value, which is 0.05, then we can say that our time series is stationary. So as we are seeing here, the p-value is greater than 0.05, which is threshold value. We can state that our time series is not stationary. So if time series is not stationary, we have to make the time series stationary by removing the trend using the first difference method. So as we have to remove the trend from the data set, we will be using the first difference method to remove the trend and to make the time series stationary. So after performing the difference method here, now the graph is being shown here, which represents the time series is stationary, and we can also perform the add flood test to check whether the time series is stationary or not. So when we perform add flood test, we have to check with the p-value. So here, after doing the first differencing method, so here I have done differencing method only once. So here the p-value is less than the threshold value, which is 0.05. So we can state that after making and after performing differencing method for once, our time series has become stationary. Yeah, so here when I perform the add flood test on the demand column, so the p-value here observed is 0.23, which is greater than the threshold value 0.05. So we state that threshold, the time series is non-stationary. And after performing the differencing method on the demand column, we can see that the demand column is stationary. And by using p-value also, we can state that it is as it is less than threshold value. So we have made the time series stationary. So now we have made the time series stationary so that we can perform the future forecast, future prediction on the demand column. So for that purpose, there are two models, ARIMA and SARIMA models, which are used for the forecasting of, which are used for predicting the future values from the historical data. So first, we will be building the ARIMA model. Now, ARIMA models use differencing to convert non-stationary time series into a stationary one. So as we have done, so we have made the differencing once to convert non-stationary time series into stationary time series. And this ARIMA model is used to predict future values based on the historical data. So for to build this ARIMA model, we have to find three values, P, Q, and D. So these P, Q, and D values will be found using autocorrelation plot and partially autocorrelation plots. So from stats models library, we can easily plot autocorrelation and partially autocorrelation plots for our data set. So here each line represents each one lag. Nothing but lag means that the time period between first recorded data and the next recorded data. So now here the shaded region is the threshold region, and we have to find P, Q, and D values for using the ARIMA model. So the P value can be found from partial autocorrelation graph. So here now we can see that the number of flags that have been the number of flags that are out of this shaded region will be considered as the p value. So here, as we check, there are two lags which are out of this shaded region. So the p value can be considered as 2. And here we have done the first differencing method only once. So d will be one value, d will be 1. And now the q value can be found from this autocorrelation plot. So here only one lag is out of this threshold value. So the q value will be 1. So we have found the PQ D values as 2, 1, 1. So from this autocorrelation and partial correlation graphs. So yeah. So here I have again splitted the data set after differencing, after doing the differencing method on the data set. So we have to split the data set again. So this is the representation of a splitted data. Yeah. And now here I have created an object for the ARIMA model where I have mentioned the PQ values in this order method. So here the P value is 2, Q value is 1, and D value is 1. And I have fitted the data. After fitting with the ARIMA model, this is the residual plots. And the root mean square error value is 387, which is very high. And if we plot the data, if we plot the tested data set and the fitted values, so here the ARIMA model has it performed very low in fitting the data. Yeah, so these are the autocorrelation and partial correlation plots from which we can find PQD and values, as I have explained now. Yeah. So here when we see, when we plot the graph between the test data and this is the fitted data, the ARIMA model has performed very low in fitting the data, because we can see that there is very large difference between the test data and the fitted data. So we have to improve the model by using SARIMA model. So this ARIMA model is not suitable for the data that very seasonal, because as we have seen that our data set contains seasonality, exhibits seasonality. So we cannot we cannot use ARIMA model. So for the data set containing seasonality, we have to use SARIMA model. So SARIMA model, the S represents the seasonality. So now the SARIMA model is used to capture the seasonality in the data set, and in the same manner we will be fitting the training set, and we will be predicting the, and we will be doing prediction on the testing data set. So this is test data, and this is this orange line represents the fitted values. So when compared to ARIMA model, the SARIMA model has performed well in fitting the values, because the difference between the test data set and fitted values is comparably very less when compared to ARIMA model. And the root, and when we found the root mean square value, it is 309, which is comparatively lesser than the ARIMA model, because in the error is very low in predicting the values when compared to ARIMA model. Yeah. Yeah. So this is the fitted graph, and this is the test graph. The graph represents the test values, and this orange value represents the fitted values. So the SARIMA model has been performed very well when compared to ARIMA model. So this graph is based on the data after we have performing the differencing method. So we have to extract the real values before. We have to extract the real values from the differencing. So as we have converted the non-stationary series into stationary series, we have to extract the original values using cumulative sum method to plot the actual data and actual predicted values. So this is the actual data before performing the differencing method, and this red graph shows the prediction values. Yeah. So up to now, we have found that SARIMA model works better than the ARIMA model on the seasonality data. So now we have to perform the future prediction. We have to find the future trend of demand in future years. So for that, we will be using the SARIMA model to predict the future demand. So here I have found the future demand for 1 year, nothing but after 2017 to from January 2017 to December 2017 for 1 year. So if we plot the data, if we plot the predicted values, now here we can see that the red line depicts the future values, future demands after 2017. So here we can see that there is some increase in the demand at the end of the year. Yes, this is the future prediction. So as we have found that the SARIMA model is better for predicting the future values. So here I have predicted the demand values from 2017 January to 2017 December. So here we can see that the future values of demand after 2017. So we can see that at the starting of the 2017 there is a decrease in the demand, and at the end of the year we can see there is some gradual increase in the demand, as we have seen that in the weekly order demand graph. So on conclusion, so I can say that we have applied all the pre-processing steps from data understanding to data cleaning and feature engineering, and I have found that the XGBoost algorithm was not able to find the trend and seasonality in the data, and it was it was not able to predict the demand values very accurately with very less accuracy. And I have performed the time series analysis on the data to observe seasonality and trend in the data, and I have decomposed the data to find a trend and seasonality, and I have forecasted the demand of the product by using Sarima model uh, at the and I have forecasted the demand of the product by using Sarima model, where I have found that there is gradually decrease at the starting of the year and gradually increase of demand at the end of the year. And these are the references that I have used for this task. And any question answers, you can please ask me. And thank you. Excuse me, sir.
Just give us a second. Yeah, okay. So I hope I'm visible now. And I hope your presentation is also done. Right?
Yes, sir. Shall I stop screen sharing, sir?
You can stop the screen share. Okay, so good presentation, I would say. Okay, it was focused more towards the demonstration part, and you have done a really good job at demonstration, I would say. Okay, yeah,
Okay.
there was demonstration as well as explanation, so that is good. But you do need to work on your you try to simplify your presentation. Okay, it was too much technical, but it can be simplified. It is good that it is technical. You explained a lot of things. You touched on a lot of details. Your outputs were well explained. Okay, but you can simplify it. Okay, your overall story and book can also be improved. Other than that, on demonstration, really well done job, well explained, I would say. Okay, so keep up with the demonstration. Other than that, just work on your story part. Okay.
Okay.
Yeah. Okay, so I believe it is already 9:07, so we cannot have any more presentations. So Salya and Bhavita, I will take your presentation next week. Okay, because today is Friday. So I will take your presentation next week. Don't worry, you will not get any kind of negative evaluation for like doing late presentation or your deadline. Okay, I will extend it from my side, so you can just give your presentation on next week. Okay, I have noted down your names. You will like get chance to give presentation before anyone else in next week's session. Okay, so we will stop here for the day. We will continue the session next week. Next week is let me see, yeah, July 4th. So I believe on 4th I will be conducting the welcome session for the new interns, that is onboarding session, and Akash Lamba or either Saurabh Singh will conduct the presentation session. You can join the session. If they are not available, then on 5th I will conduct it. Okay, so make sure that you are joining on 4th and giving your presentation to Mr. Akash Lamba or Saurabh Singh. Okay, so thank you for joining. We'll stop here for the day. Good night.